Here's another possibility with the ambiguous case for law of sines. Here we have a triangle where side B is 6 inches, so that would be over here. Side C is 9 inches, that would be down here. And we know that this angle B is 62 degrees. So if we set this up, these are the pair that we're going to put together. So I'm going to start off with sine of 62 degrees over 6 inches is going to equal, opposite of the side that we have is angle C, so sine of angle C over its opposite side, which is 9 inches. So when we start solving for sine of C, we're going to have sine of C is equal to, multiply both sides by this 9, and we're going to get 9 sine of 62 over 6. And then again, we're going to use the inverse sine function to find out the acute measure of it, and then see if there's an obtuse version of it. So if we type in the sine inverse part, sine inverse of, well, basically all that mess up there, our calculator gives us an error. Now, why is that? Well, if we just type in the 9 sine of 62 divided by 6, we find the answer of that is approximately 1.3. Now the problem with that is you can't take the sine inverse of things that are larger than 1. So the sine inverse of 1.3 does not exist, because then 1. So it can't happen. So the number of triangles we get out of this is absolutely none. So no triangles are going to come out of this one. Alright, the other possibility is this example, and we're going to set it up exactly the same. Here we have side A is 8 inches, side B is 5 inches, and the measure of angle A is 40 degrees. Alright, so we're going to go sine of A, which is 40 degrees, over its opposite side, which is 8. This is going to equal sine of B over 5. We'll have sine of B is equal to 5 sine of 40 after we multiply both sides by 5 over 8. And we're going to get B is approximately 23.7 degrees. So angle B, the measure of angle B, is 23.7 degrees. Now let's see if the obtuse portion of this angle works. So we're going to subtract from 180 to find its second quadrant equivalence. That's 156. So the second possibility is 156.3 degrees. Now is that going to work? Well, if we add 40 to it, we're going to get 196.3 degrees, which is not going to be in a triangle out of that one. So we're not going to get a triangle out of the second angle. So the only thing we have is angle B is 23.7 degrees. And now we can go through and find all the other information. Angle C, the measure of angle C is approximately 40 plus 23.7. Get that answer, take it away from 180, 116.3 degrees. And to find the last side, we're going to set up the sine of 40 again over 8. And the side we're looking for, this is 116.3, this is 23.7. The side we're looking for is this side C. So I'm going to use this angle I just found, C, sine of 116.3 degrees over its opposite side, C. I should have flipped it, but oh well. So eventually we're going to get C is approximately 8. Let's see, how would this work? Put this up here. It would be 8 sine of 116 divided by sine of 40 is equal to C. So 8 sine of 116.3 divided by sine of 40, we're going to get 11.2. So C is 11.2 inches. And that would be only one triangle out of the law of sines.